In this video, we'll solve a few complex fractions. As you can see, the fraction that I wrote below, 1 over 2 over 3 over 4, this would look as like a complex fraction because at the numerator, it has a fraction, and at the denominator, it has another fraction. We are used to having fractions, only one fraction, but here numerator and denominator are composed of fractions as well. So what do? Well, we are going to look at this line here as our division. So we can write 1 over 2 divided by 3 over 4. So our fraction is not that complicated anymore, right? So we have to divide two fractions. So we have 1 over 2 times 4 over 3, and we can either multiply across and say 4 over 6, or we can say 4 divided by 2, it's 2 here and 1 here, and then we multiply across 1 times 2, it's 2 over 3, final answer. So now let's try to do this using expressions. So let's do example 1, where we have to simplify x over 3 plus 3 over x, everything over x over 3 minus 3 over x. So we can see that we have numerator and then the denominator. So we can solve this problem in two methods. So let's solve it using method 1. Method 1 is following the same process that we did in the example before. I'm going to rewrite the numerator, x over 3 plus 3 over x, the whole numerator, and I'm going to divide it by the denominator. And because each numerator and denominator are made by more than one term, we put the terms in parentheses. Now, I'm going to look for LCD of the first fraction. So the LCD of the first expression is 3x. So I'm going to multiply the first fraction by x over x and the second one by 3 over 3 to have the same denominator. So we get x squared over 3x plus 9 over 3x. So I can write everything as only one fraction. So this whole thing became just this fraction. Now let's take care of this one. Again, the least common denominator, it's 3x. So we'll multiply this one by x over x and this one by 3 over 3 to get the same denominator. So divided by, and now x squared minus 9 over 3x. So our new fraction, our second parenthesis became, it's just one fraction. So how do we divide two fractions? X squared plus 9 over 3x times, and we flip the second one, 3x over x squared minus 9. 3x cancels with 3x, and we end up with x squared, or it gives us 1, and we end up with x squared plus 9 over x squared minus 9, and this is final answer. We cannot divide x squared with x squared, we cannot divide 9 with 9, because what this actually means is x squared plus 9 in parentheses divided by x squared minus 9. So obviously we cannot divide x squared with x squared since we have the parentheses to do first. So the final answer is this one. Now let's try to solve the same problem using another method, method 2. So to do this method, I'm going to write the problem again. So the process for method 2 is to find the least common denominator of all fractions. So least common denominator of everything. So least common denominator of 3x, 3x, of all the denominators. So of 3 and x because those repeat. So it's 3x. Now let's multiply each numerator and denominator by the LCD. So now x over 3 times 3x, we can put over 1, plus 3 over x times 3x over 1, right? I'm multiplying this with each of them. Everything over x over 3 times 3x over 1 minus 3 over x times 3x over 1. So all these terms from here are still here, but we multiply by this 3x, so it shows up in here. And I put over 1 because we are multiplying fractions. So 3 divided by 3, it's 1. And then x times x, it's x squared. So no more numerator. X divided by x, it's 1. So we have plus 9. 3 divided by 3, it's 1. So we have x times x, x squared. Minus x divided by x, it's 1. So then minus 9. And we ended up with the same answer that we got before. So we solved the first problem using two methods. So you can choose which method you like best. Let's solve a second example. This example is a little bit different than the other one because it doesn't have specific fractions here. We'll have to come up with them. So let's remember that x to negative n, it's 1 over x to the n. So I'm changing the negative exponents into positive exponents by writing 1 over them. So let's change each of them. X to negative 1, it's 1 over x, plus y to negative 1, it's 1 over y. So we changed from negative exponents into positive exponents. The denominator is x to negative 2, which is 1 over x to the second, minus y to negative 2, it's 1 over y to the second. And so now we can solve this problem using both methods or using only one of them. So I'm going to use the second method that we did before, which was using the LCD of all denominators. So the LCD of x, y, x squared, y squared, right? Those are all the denominators, is actually x squared, y squared. Why? Because we copy all the factors to the highest power. So between x and x to the second, we chose the x to the second. So now what do we do with this? Well, we multiply numerator by x squared, y squared, and we multiply the denominator by x squared, y squared. So let's see. 1 over x times x squared, y squared, it's actually x, y squared, plus 1 over y times x squared, y squared, it's x squared, y, over 1 over x squared times x squared, y squared, it's y squared, minus 1 over y squared times x squared, y squared, it's x squared. So now let's see what we can do. Between the first two, we can factor out the xy and we get y plus x, or x plus y is the same thing, right? The addition is commutative. Over the denominator is a squared, right? A squared minus b squared formula, which is a minus b, a plus b. So in this case, it's y minus x times y plus x. Y plus x divided by y plus x, it's 1. So we are left with xy over y minus x. Final answer. We cannot cancel more.